Welcome back. This is 2014 Calculus AB question number 5. And we are going to note some things. We have a differential equation. It just means you have an equation in differential form where you have the dy dx instead of like f prime. And we're told y equals f of x is a solution, a particular, so a specific solution, meaning if you take the derivative, plug it in on the left side, plug in that y from here on the right side, the left side and right side will be equal. So it's a particular solution, and we are told specifically that that particular solution goes through 0, 1. Because, remember, when you take the antiderivative of both sides, you would get a plus c. So depending on what your c is, you can have an infinite number of solutions. All that c is going to do is going to shift this graph up or down. But once they tell you, we know it goes through that 0, 1, that is a particular solution because you can't move up or down because it has to go to that point. And they want us to draw a sketch and realize that all these little dashes are basically the derivatives at those points, but it's the slope of the tangent line to the graph. So when I draw my graph, all those little dashes have to be parallel to my graph. So I'm going to draw this to the right. As I go to the right, I just make sure that all these little dashes are parallel to the curve I'm drawing. And I think that's beautiful. And so we're going to do the same thing to the left side. So I have to be going down because that's where the dashes are going. And I have to be parallel to all of those little slope field marks. And that is beautiful. So I got that. That's it for part A. Let's move on to part B. That was only 1 point, but it should be easy. If you're understanding the concepts, that should make sense and be totally easy. All right, part B, equation of the tangent line. Equation of the tangent line, you know you want the equation of a line. Immediately, you need to go to the point slope form. And we need to know x1, y1, and the slope. Well, they tell us the point that this tangent line goes through. It's going to go through 0, 1. That is our x1, y1. Now we need the slope. Everyone knows the slope is, or slope of the tangent line is the derivative at that point. So how do we get that? Well, at 0, 1, we go back to our differential equation here. Plug in 0 for x, 1 for y. So if you put a 0 here, I'll do this for you. 3 minus 1 cosine 0. Make sure I did that right. Y is 1, x is 0. So I put a 0 here and a 1 there, which I have done, which gives us 2 times 1. So we know the slope is 2. Let's plug all that in. Magic. Now I have the tangent line equation. So let me explain what's happening here. I'm going to solve for y. That's the equation of the tangent line. Let me draw a picture of that so you see what's going on. I will do it in a wonderful red. Whoa, that's not what was supposed to happen. So that's pretty good. Pretty good. So that is the tangent line that we have just found. The equation of that line is the one down below. Y equals 2x plus 1. Now they want us to approximate the value of the purple function at point 2. So I will do a yellow dot. So point 2 would be somewhere around here. It's going to be hard to see on this, but they want the value of the yellow line or purple line at that point. But since we don't have the equation of that purple line, we're going to find the y value on the red line by plugging in our point 2. into the equation of the line, that gives us the y value of that little yellow dot on our red line, tangent line, which approximates the y value on the purple line. That's all tangent line approximation is. So we would say f at point 2 is about equal to 2, evaluate at point 2 plus 1. We're done. You don't have to write anything more than that. For those of you who refuse to listen and simplify, you would get that. But don't do that, please. Stop right here. It's too easy to make a simple mistake. Part C, let's do this. We want a particular solution to the differential equation. What was it? Y minus, I can't remember, 3 minus y cosine x. 3 minus y cosine x. And normally, just to find y, if you have dy dx, we'd integrate both sides, right? Here is the problem. X is our variable, y is our function. That's our variable, which is fine. But the problem is we have a function. And how do we take the antiderivative of that function? That becomes funky. So we separate variables. You have to recognize you would lose 6 points on this FRQ if you didn't recognize you had to switch variables. You would have gotten 3 points for the previous 2 problems and lost 6. So recognize this is your function. If your function appears in the equation you're trying to find the antiderivative of, you have to separate your variables. So we have to get the 3 minus y to the left side. We're going to divide both sides by 3 minus y. And it'll cancel on the right side. And then we're going to get the dx on the other side. Beautiful. Now we have an equation. We can integrate both sides. That would make sense. In this year, they gave you 1 point for each antiderivative. So the left side, you got to be careful. Because 1 over 3 minus y, what is the antiderivative? Well, the antiderivative of 1 over y dy is just ln of y. You can't just say ln of 3 minus y, because 3 minus y is not y, it's a function. So this technically, we need to make that u. And du will be minus 1 dy. Do we have minus 1 dy? Now we do. So that's what's going on. Now we're going to substitute everything out. So let's go back to black. The negative 1 is going to follow. All of this, that will become du specifically. So I'm going to replace that with the du on top. And then if you look at the bottom, that just becomes u. That is u. 'Tis you. I thought it was you. So the derivative of what is cosine? Clearly, that's sine x. Don't forget your c. On the AP test, this particular year, they don't do this anymore. You get a point for that and for the plus c. They don't give you one for putting the plus c anymore. They're not that nice or, I don't know, merciful. So the antiderivative of du over u should be ln absolute u. Next, you have to find your c. We can go ahead and do that now, or you know what? Let's get rid of that negative 1. Whoa. Wrong gadget. Multiply both sides by negative 1. This becomes much prettier. So finding c will get you a point. So let's do that next. I'm going to do, this is side work, finding. So let's do it on the side. We're told that this graph goes through 0, 1. We're going to plug that into the equation that we found. This is the solution, but we need to get u equals, actually we got to replace that u with what u is. I will do that right now. Because we want the function y equals. So we have to get a y there. So we need this. So this is the solution, except we want y equals, and we need to know what c is. So this is good, except let's find c by plugging in 0, 1 into that equation. So we're going to get ln of 3 minus 1 equals minus sine 0 minus c. This will be ln of 2 equals minus c. So c will be ln of 2. So that's not ln squared. That will get you a point. That is side work. We are going to take this answer for c and plug it into the equation that we know it's the solution. At this point, we need to solve for y. So we're going to do that. So we need to get rid of ln. Well, I like that. You just e both sides. And that gets rid of the ln. They cancel out nicely. So that's going to get that to cancel. Now the right side, we are going to split it up. And some of you, again, are not going to like this because you just don't like things like this. But here's what's happening. I'm going to make sure that I'm doing this like I want to. They get a +2. Did I mess up somewhere? I did mess up. Let me go back a little bit. I was thinking something weird. I forgot. That's a minus c. So if you multiply both sides by -1, you get minus ln 2. So if you put a minus ln 2 there, that's going to be plus ln 2. That is positive, not negative. Okay, how did Yoshida get to this point? Well, remember, when you have exponents with the same base, how do you do it? You add the exponents. So if you add the exponents, you would get this. So that's perfectly legal. We're just doing the backwards of that. Here, the e and ln cancel. So you're going to get 2e to the minus sine x. Now, we're going to have to talk a little bit, but to get rid of the absolute value, we need a plus or minus on the right side. And then, this gets crazy, we have to subtract 3 from both sides. So -3 plus or minus 2e to the minus sine x. Then we have to multiply both sides by -1. It's still plus or minus because when you multiply negative and plus and minus, you get plus and minus still. Now, how do you know if it's plus or minus? Well, a little side work. We have to go through the point 0, 1. So let's plug that in. 1 equals 3 plus or minus 2e to the minus sine 0. Sine of 0 is 0. It's going to be 2e to the 0, which is just times 1. To get 1, clearly, hopefully you see this, you need the minus. 3 minus 2 is 1. So it's got to be the minus. So our final solution will be this. Therefore, y equals 3 minus 2e to the minus sine x. So for those of you who are freaking out on this, saying, how do I know it's plus or minus? That part gets me all confused. Well, that whole last step, everywhere, after we found c, all of this is worth 1 point. So don't freak out if you don't get that point. It's not going to kill you. So that's just an encouragement to you about separation of variables. We are done. That's it for number 6.